Start off, we're going to talk about extruders. The extruder is the heart of your 3D printer. It's responsible for feeding filament smoothly and consistently. A bad extruder can lead to clogs, uneven extrusions, and poor adhesion, all of which I have seen. There are two main types of extruders, the Bowden and the direct drive. Upgrading to a high-quality extruder like a Bondtech dual drive or a direct drive system can eliminate issues with under extrusion and stringing, giving you sharper details and stronger prints. That being said, what's the difference? Is it worth upgrading? And do you need to upgrade to a high-quality version, or can you do a stock version of these direct drive systems? So Bowden and direct drive extruders both have strengths and weaknesses. They're good at different things, and choosing the right one depends on your specific 3D printing needs. Let's break down the key differences. First, the Bowden driver, it has an extruder motor which is mounted away from the print head, and it's usually somewhere on the print frame itself. The print filament is then pushed through a PTFE tube or a Bowden tube to reach the hot head. You can see that in the image that I am providing. The direct drive is a little bit different. It has the extruder motor mounted directly to the print head, right above the hot end. So you have very little distance between the motor that's pushing the filament and the heat that is causing the filament to be extrudable. This allows you to extrude materials that you can't really do in a Bowden tube. So what are some of the pros and cons? Well, a Bowden extruder is typically lighter weight print head, which means you can usually get faster movements with less ringing or ghosting. It has less precise control due to that longer filament path, which could be good or bad depending on what you're trying to achieve. Works very well with PLA, ABS, and PETG filaments, so if you're using those, then Bowden's perfectly fine. But it does struggle with your flexible filaments. As far as maintenance, it's usually a lot easier to maintain having that distance gap. The complexity of your extruder head is much less. Retraction typically has to be higher though, because you have that extra length of your tube. You have to retract your filament more if you're going to do so in order to get the goals you're trying to achieve. As far as print quality, it's great for general purpose printing. So if you're just printing at home, it's probably perfectly fine. But if you're trying to get some detailed prints, if you're trying to make some complex geometries, you're trying to make some unique things, it can struggle with that. Inversely, a direct drive extruder typically has a heavier print head, which can cause more vibrations, which if you don't account for that, can lead to some errors in your prints. But if you do account for it, it does give you more precise extrusion control, which is better retraction, and you have less stringing because of it. Usually means you can actually print faster. Excellent for flexible filaments like TPU and TPE filaments. It does have higher maintenance costs and maintenance difficulty because it's attached straight to your hot end. So if you have an issue with your hot end, that's a lot that you have to get into to fix. It requires lower retraction settings because your filament's right there, so you have that more precise control. And because of that, it's very ideal for detailed prints and flexible filaments. So which one should you choose? Well, if you're looking to print fast and you want minimal ringing, ghosting on your prints, you're going to use traditional filaments like PLA, ABS, or PETG, then go for the Bowden extruder. It's a lot easier to maintain, and it's often cheaper. That being said, if you're looking to print flexible filaments, well, then you're going to have to get a direct drive system. If you're looking for more precise extrusion or higher quality prints in general, then you're going to want to upgrade to a direct drive. Personally, I have a direct drive on my system, and I find it works beautifully. It's a commercial, off-the-shelf, not high-end direct drive extruder, and it works just fine for my needs. So in summary, if you frequently print flexible materials or you want better retraction control and precision, a direct drive extruder is worth the upgrade. Upgrade number 2, precision bed leveling system. So one of the most common issues, and I ran into this a lot when I was getting started, is bed adhesion. And that's often from an uneven print bed. So if your first layer isn't perfect, then everything after that can go bad. And for me, usually within a few millimeters, if I had a bad adhesion or bad leveling, then the print would debond and I get the mess. So what can we do? Well, you can always upgrade to an auto bed leveling sensor like the BL Touch or the CR Touch, which ensures consistent leveling of the bed every time, and it leads to flawless first layers with no manual tweaking needed. So that being said, between auto bed leveling and manual leveling, which one is actually better? Well, ultimately, you need a properly leveled bed for high quality 3D prints. If you have uneven leveling, you can have poor adhesion, inconsistent layers, and even just straight up failed prints. So should you stick with manual leveling or upgrade? That comes down to you and your needs. So what's the difference? Manual bed leveling, you're adjusting it by hand. So you're turning knobs on the underside of the print bed in order to get it leveled. And typically you have a feeler gauge or often just a piece of paper that's used to check the gap at every point in your printer as you're manually adjusting this. And because it's manual, it requires periodic adjustments as the bed's going to shift over time, especially if you have to replace your bed because of wear. Auto bed leveling, on the other hand, automatically measures the bed surface using a probe like the BL Touch or the CR Touch. It creates a mesh map of the bed's inconsistencies and then compensates for them during printing in the code. So you don't have to level it, and any drift over time is going to be accounted for by the new mesh map that's generated every time you start a print. Now, it's generally slower because you have to do this calibration each time to get the good bed leveling. You can choose to skip it, but if you do skip it, then you're at the mercy of how level your bed is to begin with. So what are the pros and cons here? Well, for manual bed leveling, it requires patience and experience. It takes time. The more you do it, the easier it gets, but you have to tweak it often. It is not great for small misalignments. You can't always detect those if you're using a piece of paper or a feel gauge to try to check your height. And so you can have issues from these small misalignments. And again, it's manual, so it is time consuming, but it does work well if you can get it to work. Installation complexity, we can look at. There is no installation. It's just the bed. You adjust screws and that's it. And because of that, it's free and comes naturally with the printer. Now, sometimes some of the newer printers will have the CR or the BL Touch already included, so it's free with the printer, but your printer is going to cost a little bit more because it's coming with that particular device. As far as the auto bed leveling, there's nothing manual about this. The printer does the work for you. It compensates for all the variations and gives you a very consistent first layer. And because of that, it can save time between prints, but during a print, it does take longer since it has to calibrate. It adapts to the shifts that happen over time, so nice and easy there. But it does require a sensor and firmware updates potentially, depending on the printer you have. If your printer already came with this, then you're good. If it did not, then you're going to have to do that. And that does mean that you have an extra cost of anywhere between $30 to $60 for a BL Touch or a CR Touch probe. I recently replaced my CR Touch because of issues. You can see that video. I'll have it linked below. And that ran me, if I remember right, about $59 just for the CR Touch, but I did get a kit that had everything with it, which was very helpful. So which one do you choose? Well, personally, I'd say stick with manual leveling if you don't mind adjusting the bed occasionally. If you're fine with that manual interaction, leave it. It'll save you money and you won't have to modify your printer. And it's going to be great if your bed is quite stable. Now, if you print frequently and you don't want to have to deal with that manual leveling every time or quite often, then it might be worth upgrading to your auto bed leveling. It also is important if your printer bed is slightly warped or prone to shifting, and mine is. So you definitely have some warp going on in there. If you want a first layer to be perfect every single time without having to tweak things, that might be another reason to upgrade. So in general, I think auto bed leveling is worth it if you're struggling with that first layer. But if you're being successful right now, then you don't need to upgrade. Another upgrade that you can do is changing your filaments. So PLA is kind of your typical go-to filament. It's fairly easy to print, it's easy to work with, but there are others for different reasons, like ABS, PETG, TPU. ABS being a high strength, good durability filament with difficulty printing. TPU being very flexible filament that you can work with. So not all of your filaments are the same, and it can alter what you're trying to get out of it. So upgrading, again, let's say you want a more durable part, ABS might be a nice piece to work with. PETG or TPU if you want some flexibility to your print, you want it to have a little bit of give to it. Or honestly, you could even go with carbon fiber infused filaments, metal infused filaments. There's so many options now to change the results of what you're trying to get. Generally, what it boils down to is this. Better filaments means a stronger part. And that could just be that instead of using a stock PLA, you go for a higher quality PLA from a reputable supplier. And by doing that, you can end up with smoother surfaces, improved performance if you want function from your parts, not just looks. Speaking from experience, it's easier said than done. I've attempted to go to ABS and I can print somewhat okay. I've dealt with some of the issues, but there are others that still exist and I haven't overcome all those yet. So that's up to you if you want to achieve that. Upgrade 4 would be improving your cooling system associated with your printer. So printers typically come with lower end fans that do a decent job, but may not be enough depending on the filaments and the prints you're trying to achieve. Proper cooling is crucial for those details, especially overhangs if you're not going to use supports. Many stock printers, again, come with this feature, but they're fairly weak and don't really distribute the airflow where they need to be. So upgrading to a better cooling fan or a custom fan duct like the ones I'm showing on the screen can prevent warping, improve bridging, and result in crisper details, especially for PLA. The last upgrade, and this one I do recommend, and I'm working towards this one myself, is an enclosure in order to regulate the temperature better. So the cooling fan works well at the nozzle location. You have a heated bed, but you're at the mercy of your ambient conditions when you're printing everywhere else. So this is particularly important if you're printing with something that's not PLA, like ABS, nylon, or any of the high temperature materials. You're going to end up with high temperature filament being extruded, high temperature at the bed, and a cooler temperature in between, and that can lead to defects, particularly warping, layer delamination, and those kinds of issues. So if we can enclose the printer, then the temperature kind of stabilizes, smooths out because of that, and you get a better result. So you could go with a do-it-yourself solution, which is what I'm looking at. You can literally get some wood, you can get foam, you can get really anything you want, and encase the printer to control the airflow. There's some interesting examples you can see on the screen here that work. You could also go ahead and buy a cabinet specifically designed for this function. Before you start upgrading, though, what you should keep in mind is your budget, your compatibility, and installation difficulty. So if you're going to upgrade, you're going to need to prioritize upgrades that are going to make the biggest difference for your printing needs. For example, do you go with a cabinet? Do you go with a new extruder? Well, if your extruder is working well on the filaments that you're using, then maybe the cabinet is the way to go. Or maybe the auto leveling system is the way to go if you're having delamination issues. Compatibility is important because certain components don't work with every printer, so you need to make sure that if you're going to buy a BL Touch or a CR Touch, for example, that your printer can accept the firmware and the software to be able to do this. And then installation difficulty. Some things are very plug and play. In my case, I already had the CR Touch installed, so all I needed to do is swap it out. Sometimes it's not. If you don't already have that installed, then you're going to have some technical know-how to integrate a new tool or an upgraded feature into your existing printer. But don't be afraid to ask, check tutorials, seek community support. There's a lot of material out there on this. Some of it I'll have linked in the description below. Ultimately, if you're going to go forward and upgrade, you need to figure out where you're going to buy these, and you can get them from places like Amazon, MatterHackers, Micro Center. But ultimately, you want to go with a reputable retailer. So if you're going to buy from Amazon, for example, Amazon is not the seller itself. sell for and on behalf of other people. So you want to make sure that the companies that they're bringing in, the components they're bringing in, are quality. So check your reviews, seek input from the community as well. And there are some links in the description to some of these websites that you can use. And if you need additional guidance, YouTube and other online forums are full of helpful tutorials, and I will be supplying more as we keep going. So in conclusion, upgrading your 3D printer is one of the best ways to improve your print quality, reliability, and versatility. With the right upgrades, you can unlock new possibilities and push your printing to the next level. Out of curiosity, what is your favorite 3D printer upgrade? Please comment below if you've actually gone through any of these upgrades or if any of these are interesting to you. If you want more details on any one of them, I'm more than happy to provide that. But I want to hear from you. Drop a comment below, and if you found this guide helpful, don't forget to like, subscribe, and hit the notification bell for more 3D printing tips.